Welcome to another example on how to graph the standard equation of a parabola when the vertex is not at the origin and the parabola opens left or right. The first thing we should recognize about the equation is that the y part is to the second power and we have x to the first. This is the reason why the parabola will open left or right, which means we're working with the standard equation in this form here. So for a quick review, if the x part was squared and the y part was raised to the first power, then we'd have a vertical axis, meaning the parabola would open up or down. But again, in our case, the y part is squared and the x part is to the first power, so our parabola has a horizontal axis and the parabola will open left or right based upon the sign of A. So going back to our example, I'm going to write this equation again so it matches this form perfectly, which means I'm going to write this as the quantity y plus 1 squared equals 3 times the quantity x minus 0. I don't need to do this, but it does make it easier to find the coordinates of the vertex. The vertex will have coordinates hk, and since we have x minus 0, the x coordinate is 0, and because we have y plus 1, the y coordinate is negative 1. Next, to determine if the parabola opens left or right, we'll find the value of a. If a is positive, the parabola opens right, as we see pictured here. Notice how it opens along the positive x-axis. If a is negative, the parabola would open left. Notice that 4a is equal to positive 3. So if 4a equals positive 3, we divide both sides by 4 to solve for a. Notice a is equal to 3/4, or if we want, positive 0.75. So because the value of a is positive, our parabola is going to open right. So now to help us find the focus and directrix, we're actually going to make a rough sketch of a parabola with a vertex of 0, -1 that opens to the right, and then after we find the endpoints of the focal diameter or latus rectum, and then we'll sketch a more accurate graph. So the vertex will be the point 0, -1, or this point here. And then because the parabola opens to the right, the graph would look something like this. The reason this helps is because we know that the focus will be to the right of the vertex or inside the parabola, and the directrix will be to the left of the vertex or outside the parabola. And the distance from the vertex to the focus, or this distance here, is equal to the absolute value of a, and so is the distance from the vertex to the directrix. And since a is equal to 3/4, which means the focus will be 3/4 or 0.75 units to the right of the vertex, approximately right here. Which means the coordinates of the focus would have to be 3/4 -1. Or if we want, 0.75 -1. And then the directrix would have to pass through a point 3/4 of a unit to the left of the vertex. So the directrix would have to pass through this point here. So the directrix would be this vertical line. And therefore, the equation of this vertical line would be x equals -3/4. Or x equals -0.75. So notice how if we understand the properties of the parabola, we don't have to memorize formulas in order to find the coordinates of the focus or the equation of the directrix. But if we did want to rely on a formula to find the focus, we could add a to the x-coordinate of the vertex. Notice that 0 plus 3/4 would be 3/4 or 0.75. And then to find the directrix, we could subtract a from the x-coordinate of the vertex. Notice 0 minus 3/4 is -3/4 or -0.75. And then for the axis or axis of symmetry, because our parabola opens left or right, we'll have a horizontal axis passing through the vertex and the focus, which would be this horizontal line here, or in our case, this horizontal line. And therefore the equation of this horizontal line would be y equals -1. Notice how this is also the same as the y-coordinate of the vertex and focus. And then finally, to find the endpoint of the latus rectum or focal diameter, Going back over to our notes, the latus rectum is this segment here. Notice how it's parallel to the directrix, passes through the focus, and also has both endpoints on the parabola, and the length of this segment is equal to the absolute value of 4a. Well, we know 4a is equal to 3. The absolute value of 3 is 3, so the latus rectum will have a length of 3 units. And since the focus is also the midpoint of the latus rectum, or focal diameter, starting at the focus, we would have to go up 1.5 units to find one endpoint, and down 1.5 units from the focus to find the other endpoint. So analyzing the coordinate plane, this endpoint would have coordinates 0.75, 0.5, or we could also give this as 3/4, 1/2, and the other endpoint would have coordinates 3/4 or 0.75, negative 2.5. We can also give these as fractions. It would be 3/4, negative 5/2. And now that we have these endpoints, which we know are on the parabola, we can make a more accurate graph of our parabola. The segment here again would be the focal diameter, or latus rectum. So this is the vertex of the parabola, so the graph would look something like this. I hope you found this helpful.